Module 3, Performing Calculations with Formulas and Functions. The objectives of this module are as follows. Translate an equation into a function. Do calculations with dates and times. Extend data and formulas with autofill. Use the function library. Calculate statistics. Use the quick analysis toolbar. Use absolute and relative cell references. Use a logical function. Retrieve data with lookup tables. Do what-if analysis with goal-seek. In this first illustration, the first box on the upper left-hand side of the screen is pointing to the function library that you'll find on the formulas toolbars. In here that you'll find a large collections of useful functions that will make your life easier when doing various calculations. There are a lot of them in here. The odds are, if it's a common formula, it's going to be in here. The Insert Function button, which can both be found on the function library, or if you look just below the function library group, you'll see the F of X button. If you click on either of these, it'll open up a dialog box that you can use to search on functions instead of having to go through the different groupings. A little lower on the screen towards the middle on the left, there's a bubble that's pointing to the average function. You'll notice that in the average function, that instead of a normal cell reference with a row and column, it just has H:H. When you see this, you know it's referencing an entire column, not just a range, but the entire column. So in the function average, it's going to give you the average of the values in column H. It'll only be looking at the cells that have numeric values. The median function will return the middle value of that same range. The mode.sngl function returns the single value that is repeated the most often in a range. The next two functions, min function returns the smallest value or the lowest number within the range, and max returns the largest or highest value within the same range. In the middle, towards the bottom, the bubble is pointing to cases, and these are filled using the autofill function. In your homework assignment, you'll be entering the first value, and then by using autofill, it'll automatically fill the cells below it. And if you notice, the numbers aren't all the same. With autofill, one of its really neat features is that it can automatically increment. If you start with a single cell and you use the autofill, it'll increment by 1. If you have an increment that's different within the range and you select multiple cells, so if the first one might have been 27, the next one was 37, if I did the autofill after selecting both of those, it would increment them by tens. Over onto the right, the top bubble is pointing to a group of cells that have made use of the roundup function. This function rounds a value up to the next highest digit. The values you see below that, pointed to by the bubble with autofill in it, is showing you a range of cells that were filled using autofill. The first formula was put into cell J5, and the autofill was used to populate the cells below it. When you do an autofill, you will see the autofill's options button appear. You'll see that on the lower part of the screen. The third bubble down on the right is pointing to that. If you click on that, you have additional options that you can choose to affect how that autofill worked. The one that you'll be using frequently in this assignment is to fill values only and not the formatting. And that last bubble on the very bottom, just below the zoom slider bar, is pointing to the autofill handle. By pointing your mouse at that little square, you can do autofill. Now, a shortcut that you find useful when you're filling a large range, so long as a column next to it is fully populated, if I double click on that autofill handle, it'll fill down for as far as it's automatically populated. Now, don't just assume this is going to work. You want to look at the cells. If I'm trying to fill 100 or more cells beyond this and I'm dragging down, I'm going to have to wait for cell to kind of scroll the screen up. So if you scroll through your spreadsheet and look at the data, if the column, in this case we're looking at the durations, if the field next to that is full, when I double click it'll automatically fill, which is way faster than clicking and dragging for 100 cells. Designing a workbook for calculations. A workbook with many calculations can be challenging for the author to write and for others to use. To help everyone, it is important to list the formulas used in the worksheet and to explain the assumptions behind those formulas. The workbook documentation should also include the definition of key terms to make it clear what is being calculated and why. Some equations use constants, which are terms in an equation whose values don't change. They're likewise something you're going to be using in more than one location. Calculating with dates and times. I mentioned in one of the prior presentations, Excel will store dates in an international date format. Excel stores dates and times as a number of days since January 0, 1900. Full days are whole numbers and partial days are fractions such as 0.5 for half a day or 12 hours. Storing dates and times as numbers makes it easier to calculate time and date intervals, autofilling formulas, and data patterns. One way to efficiently enter long columns or rows of formulas and data is with autofill. Autofill extends a formula or a pattern of data values into a selected range and is often faster than copying and pasting, which requires two distinct actions on the part of the user. Exploring autofill options. By default, autofill extends both the formulas and the formatting of the initial cell or cells. However, you might want to extend only the formulas or only the formatting. Filling a series. Use autofill to create a series of numbers, dates, or text based on a pattern. To extend a series of data values based on a pattern, enter enough values to establish the pattern. Select those cells containing the pattern, and then drag the fill handle, extending the pattern into a larger range. Use a series dialog box for more complex autofill patterns. Applying Excel functions. Rounding data functions. The two that you'll be using here are round down and round up. And round down rounds down to the next value, and round up rounds up to the next value. Calculate minimum and maximums. The min and max functions return the smallest and largest value from a specific set of cells. And you'll see the syntax here on the screen for both of those. Measuring of central tendency. The three functions we'll be looking at here are mean, median, and mode. Nesting functions is when you put one function within another. A row of blanks and zeros. Many workbooks include the current date. Use the today function to display the current date in a worksheet. The today function is displayed here on the screen. It's equal today, and you'll have the left and right parentheses with nothing in between. It has no arguments. The date displayed by the today function is updated automatically whenever you reopen the workbook or enter a new calculation. Figure 3-18 can be found in your textbook. It has a series of the date and time functions. It's not a complete list of all the functions. The two that I find I use the most are now and today. Please take a look at those. Now returns the current date and time. Today returns the current date. And the other functions you can look at your leisure. Interpreting error values. An error value indicates a sum or part of a formula was entered incorrectly. Error values by themselves might not be particularly descriptive or helpful. To help you locate the error, an error indicator appears on the upper left corner of the cell with the error values. Now here are some of the errors that you're likely to see. None of these are uncommon. Please take a look at figure 3-19 in your textbook and read through each of these carefully. And this illustration can be found in the textbook. The first two bubbles are pointing to different types of cell references. If you look in cell A7, you will see equals $B, $5. When you see the $sign in front of the row and column indicators, that tells you that is an absolute cell reference, which means if I copy and paste that formula to another location, or I just use the autofill to pull it down, that reference will never change. It'll always be pointing to cell B5. On the other side of the multiplication symbol in that equation, you'll see B $A. This is a mixed cell reference. So if I copy and paste this formula or drag it to another location, the column reference can change, but the row reference will not. So that 8 will never change. Below that, you'll see equal B11 divided by B6. This is an example of relative addressing. The math that's being performed with this equation is relative to the location of the formula. So if I move the formula to another place, it'll do an operation on the numbers in those new relative locations. So those references will change based on where you move it to. The very bottom bubble on the left-hand side is talking about the VLOOKUP functions. The VLOOKUP function allows you to retrieve data from a table. On the right-hand side of the screen, you see a lookup table with 3 columns: operators, hold probability, and expected hold. In VLOOKUP, column 1 is operators, probability is 2, and expected hold is 3. Just below that, we have an if function. An if function is a logical function that tests for a condition, then returns the value if the condition is true, and another value if the condition is false. You'll notice in this formula within the parentheses, B16 is less than or equal to B7, and that's the comparison. If that is true, a yes will be displayed. And you'll notice the yes is enclosed within quotes. If it's not a cell reference and it's text that you need to be able to see, it must be enclosed within those double quote marks. If the evaluation of that comparison is false, then a no will be displayed on the screen. And again, note the double quotes around the word no. The lookup table you see on the left is what is being used on the vertical lookup. So when the vertical lookup occurs, it'll be looking up the value based on what's in the operator column, and it'll return a value based on its column position. In the formula over here, we'll see a 2 and a 3. The first one's will return the values on hold probability. The second one is on the expected hold. Calculating running totals with the Quick Analysis tool. The Quick Analysis tool appears whenever you select a range of cells, providing easy access to the most common tools for data analysis, chart creation, and data formatting. It is an excellent tool for doing useful calculations and entering Excel functions. Exploring cell references. Talked about these briefly before when I was looking at that illustration. Relative cell references. Excel interprets a relative cell reference relative to the position of the cell containing the formula. For example, if cell A1 contains the formula equals B1 plus B2, Excel interprets the formula as add the values of the cell 1 column to the right, B1, to the value to the cell 1 column to the right and 1 row down, B2. Absolute cell references. An absolute cell reference remains fixed even when the formula or a function is copied to a new location. Absolute references include a $sign before each column or row designation. For example, B8 is a relative reference to the cell B8, while $B, $8 is an absolute reference to that cell. Mixed cell references. A mixed cell reference contains both relative and absolute components. For example, a mixed cell reference for cell A2 can either be $A2, where the column is the absolute component and the row is the relative component, or it can be entered as $2 with a relative column component and a fixed row component. You can easily cycle between relative, absolute, and mixed cell references and formulas by selecting the cell reference in the formula and pressing the F4 while in edit mode. I find that's the method I use most often for absolute references, is to just enter the cell address and then press F4 until I get to the right combination. Working with the if logical functions. Returns one value if a condition is true and returns a different value if the condition is false. Value if true is the value returned by the function if the condition is true, and value if false is the optional argument containing the value if the condition is false. The equal symbol in if function is a comparison operator, which is an operator expressing the relationship between two values. Formatting input, calculated, and output values. Formatting cells based on their purpose helps others correctly use and interpret your worksheet. The Cell Styles gallery includes cell styles to format cells containing input, calculation, and output values. Looking up data. Lookup functions find values in tables of data and inserts them in another location in the worksheet, such as a cell or in formulas. An exact match lookup is when the lookup value must match one of the compare values in the first column of the lookup table. An approximate match lookup occurs when the lookup field value falls within a range of numbers in the first column of the lookup table. To retrieve a returned value from a vertical lookup table, you must use the vertical lookup function. The syntax is on the screen. You notice the lookup range by default is true. If you would prefer to use the opposite condition, you would need a false. If the value is true, it is an approximate match. If the value is false, it is an exact match. The lookup table contains the following columns: operator, hold probability, expected hold in seconds, and failure rate. Performing what-if analysis with formulas and functions. A what-if analysis lets you explore the impact that changing input values has on calculated values and output values. One way to perform what-if analysis is by changing one or more of the input values to see how they affect the calculated results. The trial and error method requires some guesswork as you estimate which values to change and by how much. To perform what-if analysis by trial and error, change the value of a worksheet cell, the input cell, observe its impact on one or more of the calculated cells, the result cells. Repeat until the desired results are achieved. As you can imagine, this can take some time. Using GoalSeek. You will like this feature. GoalSeek automates the trial and error process by specifying a value for a calculated item. To perform what-if analysis using GoalSeek, on the Data tab in the Forecast group, click the What-if Analysis button and then click GoalSeek. Select the Results cell in the Set Cell box and then specify its value, or the goal, in the To-Value box. In the By Changing Cell box, specify the input cell. This is a cell that will change in order to get the goal that you're looking for. Click OK. The value of the input cell changes to set the value of the result cell.